Hey, it's Jim Alfredson here on VKS, and today we have a Siel DK600, an Italian-made 6-voice 2-oscillator synth with some really weird architecture. And this one was kind of a challenge because I've never worked on one of these before, and the original service manual that I downloaded from the internet for free was a really bad scan, so it was hard to actually make out anything on it. So I'll interject here from the edit chair, so to speak, a couple times during the video because I learned things after the fact. So anyways, hope you enjoy, and I hope this video helps you out if you're trying to fix one of these. On the bench we have a Siel DK600. This is an Italian-made hybrid synthesizer. It's using DCOs, which are kind of, I don't quite understand how it works. I think it's kind of a divide down type of technology, like it's a very high frequency digital oscillator, or maybe, no, it's still analog. It's a high frequency analog oscillator that they then divide down to get all the notes, I'm pretty sure, in real time based on inputs from the data bus. So it's not a divide down technology. It is a DCO, a digitally controlled oscillator, but it is an analog oscillator that's digitally controlled, and it's generating, each chip is generating 6 independent outputs. That's why it's a 6-note polyphonic keyboard, and then there's 2 chips, so you have 2 DCOs per voice. There still is absolutely no information on the web about this chip, so all we have is really this schematic right here that kind of shows the outputs. And you can see it's generating a 4-foot output and an 8-foot output for each voice at the same time. And my understanding is that the CPU tells it what note to actually generate based on what's coming in from the data bus, and it just makes it in real time. That's my understanding. When I first turned this on, it was just stuck. Nothing worked. I've got it to the point now where if I turn it on, the display comes up. That was not happening before. Some of the buttons do work. There's no patches in it because the memory's done. That's the noise. And we've got one oscillator working now. So the chips that do the high frequency oscillation are, I'll show you. If we lift this up, look at that. Voices 6, 5, 4, 3, 2, 1. But they get their master signal, the master oscillator essentially, from these 2 chips over here. This is the B chip, this is the A chip. Now, when I first got it actually working, relatively working, we still have a couple buttons that aren't functioning. To get the buttons functioning, which they weren't before, I just undid all these ribbon cables, cleaned the contacts, put them back in, and it actually kind of came to life. But we're only getting one oscillator out of the 2. I cleaned all the contacts, and I also noticed that the battery, this has a battery issue too, in that if this battery is original and it leaks, it destroys all this around it. Luckily this one doesn't have that. Somebody changed it a while ago, but I'm sure this is long dead. It's just a standard 2032. It's not going to last very long. Anyways, I undid all these ribbon cables, and they're kind of like socket ribbon cables, which aren't the best because the pins are very delicate, and it's possible, if you're not really paying attention, to plug them in and a pin is sticking out. And I actually did that on this one time, but I've double and triple checked. That's not the problem now. So there's still a couple buttons that aren't working. However, like I said, when I first turned it on, I was getting oscillator B, but no oscillator A. So what I did is I swapped those 2 chips, the ones that are making the high frequency oscillator. Get this kind of in camera if we can, close enough. So I swapped those 2 chips, and now button needs clean, but now we have oscillator A is working. Which it wasn't before, and now oscillator B is not working. So that means it's the chip. And this is a very strange chip. It's a Texas Instrument RI104A. Very strange chip. Let's look it up on the old iPad here. RI104A data sheet. It's not finding it. Maybe it's in. No, that's the manufacturer date. Oh, that's the number. TMS 3631. That's what it is. It's weird because the schematic doesn't have the chip. It has the number of the chip, but it doesn't have the, like the, it has the IC number, IC48, IC47, but doesn't have the actual, what the actual chip is. 3631 data sheet. There we go. Oh, great. Texas Instrument, who manufactures this chip, knows nothing about it. Couldn't find a data sheet out anywhere. So, yeah. No data sheet to be found. It says there are two variants of this chip generating different note footings. 3631 R1104. That's the one we have. Generates the octave pitches 2, 4, 8, 16, and the R1105, the third of a foot ones, 10 2/3, 5 1/3, 2 2/3, 1 1/3. Interesting. Channel 1 on each chip can only generate the highest pitch and not mix different sub-octaves. Interesting. All right, so that's a rare chip. I just happen to have a Siel 700 that came in the same lot. And it has some pretty extensive battery damage. It might just be doobied. But if it's using the same chips, so let's turn this off. And I'm going to look up the 700 schematic and see if it's actually using the same chip or not. Place your bets. Well, unfortunately, as I said earlier, the schematics do not tell you what the chip is. So it looks like it's the same based on the schematic and the pinout and all that. Sorry, I'm trying to clean up my bench because it's getting crazy. But I don't know. I already had this one open earlier today, but I didn't think to look at the chips and what it was using. So unfortunately, that means I need to open it up again. And if I remember correctly, the keyboard isn't as cool. It doesn't just flip up. You have to actually unscrew the whole thing. So to get this open, there's a couple screws on the side, and then the top will flip open, and my guess is that those chips are under the key bed, just like they are on the other ones in the 600. So the 700, as you can see, is like moving towards the more like DX7 aesthetic that everybody started moving towards, where they got rid of all the knobs, and they started making it chewy. Excuse me, these things are dusty. They started making it so you have to, if you want to change, the ADSR, well, here's the attack, it's number 30, so you go to, I don't know, I'd have to read how to do this, but I'm assuming press edit, type in 30 and enter, and then you can change the value. It sucks. It's what everybody was starting to do to kind of both emulate the clean layout of something like the DX7 and also to cut costs, because the DX7 was destroying all other synths in the universe. Okay, so this will open up, and yes, you can see it's pretty similar. This is a voice board, voice 1 or 6, 5, 4, 3, 2, 1. Same kind of idea, but this doesn't flip up, so we're going to have to unscrew it because the main board is underneath it. So thanks a lot, you Italians, for not making this one as easy to get into. Thankfully, I think it's only 6 screws. So this one booted up, but it wasn't making any sound whatsoever. But that could be because it doesn't have any patches in it either, and I don't know how to program it yet. It also has some damage, like I said, on the main board, the CPU board, from a battery. I took the battery out, so it won't do any more damage. Okay, here we go. And yes, right there. They are the same chip. It's almost the same board. Looks pretty dang close. Here's the battery leakage. I'll grab the camera so you can see for yourself. Right there. I cleaned some of it up, but probably going to have to, if I want to get this working, probably going to look in this area and see if there's any damage traces and all that kind of stuff. So in the meantime, let's pull both of these chips because one might be dead. They both might be dead. Who knows? Look at the pins on these. See how black they are? The other ones had the same issue, and I had to clean them. But yes, these are the exact same chips. So let's just pull both. I'm going to clean. There we go. I scratched it, sorry. I'm going to clean the pins on both, and we'll try one and we'll try the other. And we'll see if we can get voice A to work now, or voice B now, because we swapped it over. So to clean the pins on this, I just take a little wire brush and very gently scrape this gunk off. What are you doing in here? Get out! Arnold does synth repair. Why is the filter not working? Ah. It's only 24 dB for pole. It's not 2 pole. Alright, okay, here we go. Now, what did I say? B is this one. Let me double check that on the schematic. Channel A is chip 48. Yeah, so channel B is this, which is strange, but those Italians, I'm telling you what. Okay, do we have any pins getting shorted? No, I don't see anything like that. All right, set that one aside. Let's use one that doesn't have any monkey business going on. I feel like I need to get in here and like clean these out. This is weird. Don't want any shorts. No shorts. Okay. Goes in like this. Beautiful. This wire, by the way, is my little ground wire for my scope. I couldn't find a good place to get a ground with the scope, so I just did that. All right. Plug it in. Place your bets. Is it going to work? Yep. Oh, maybe not. Yes. Yes. So you'll notice that sometimes a note doesn't work. So there's a problem with note 5. No, note 2, I'm sorry. So as I was saying, you might notice that sometimes the note doesn't work. You can hear it really quiet. I don't know if you can hear that. It's there. It's just really quiet. So that's good. That means the chips are working. And it has a little LEDs that tell you what voice you're on. Right now we're on voice 3. I don't know if you can see that. It's really dim. 4, 5, 6, 1, 2 is the dead one. So somewhere in this part of the circuit, we're getting almost no output. I need to study the voice circuit and see where that's coming from. Most likely it's an op amp because the actual chips, the filter chips and everything seem to be working fine. In fact, Let's change the filter. We'll turn this. There it is. Yeah, you can hear it's going into self-oscillation, the filter is. So the filter is working fine. So my guess is it's something after the filter of that channel. Otherwise, we would not hear that resonance as loud as we did. So that gives us some place to start looking. And then I still have to figure out why these buttons are not working. I can't change my wave shapes. I can't change my destination for the LFO, but all these buttons are working, which is nice. That's working, that's working, that's working. But these 5 buttons are not working. They're probably all going to the same chip, and that chip is probably pooped, is my guess. And then, of course, we have to figure out how to load the patches in, because it has no patches in it right now. But we're pretty close. It's not in as bad shape as I thought. It's got a cool sound. Gotta fix that voice. And we gotta mark this chip as dead. Big old X on it. Dead. The other one, I don't know if it's good. We should probably test it. And then if I do want to get that 700 up and running, I'm gonna have to find one of those chips. Boo. All right. I'm gonna end it there because it's late and I need to get to bed. I'm flying out of town tomorrow. But our next step would be to look at the next step would be to break some keys. Now our next step would be to look at a voice, which would be here. There's our VCF. Here's op amp feeding into the VCF, I think. And they have all these test points, and if you can find the test points, you can start looking around and seeing if you can see the signal. So it mixes both waveforms into this little mixer IC, which is another op amp. That could be a potential. We can check test points and see if we're getting signals, which I already did, and that's what helped me determine that generator B chip was dead, because I traced it all the way back to the beginning of the voice and there was nothing there, and then I went back to that chip, saw that there was nothing there. So my guess actually might be IC13, this guy right here. We could check test point 5 and see if we're getting anything there. IC13 would be this guy right here. IC13, yep. That guy right there. And it looks like it's being used by both voices. Because there's only one. There's not one over here. There's one here, and there's one here. So it must be taking taking the signals from each voice, because there's 2 op amps on that chip. So test point 5 would be what we want to look at real quick. Oh God. My laboratory is getting crazier and crazier. I'll have to pick up all those later. I dropped a bunch of screws. Okay, take a probe. Where's test point 5? There's test point 2, 3, 4, 10, 9, 5 right there. And that looks like this voice right here is test point 5 for this voice. Okay, test point 5 for this voice. Oh yeah. So there's nothing coming out of test point 5 here, if you can see the scope. I'll zoom in on the scope. See, it's just high. And here's test point 5 for the other voice that's actually working. Like that. That's a nice waveform. That's jack squat. So test point 5, if we look at the schematic, zoom back out here. This is high quality camera work. Test point 5 is right after the mixer, right here. There's nothing coming out, so we should check the input on 2. Test point 2, no, 2, 3, 1, 2, 3. I don't know what that means. It's pin 6 in any case. Oh, I see. These are the alternate pins for the other channel. It's really confusing. So for us, it would probably be, I don't know. But we should see inputs on 2 or 6. I think is what that's telling us. And they're going to be quieter, obviously, because it's before the op amp. It's the input into the op amp. Okay. 2, which way is this chip going? 2 is right here. I don't see anything. 6. Yes, there's something there. So there's nothing coming into 2. So we gotta go back further. What's feeding 2? This op amp, test point 4. Could be this transistor. Could be this op amp here. So let's go to test point 4. Test point 4 is right here. Yes, there's something there. Show you. See that? Test point 4 on that voice is working just fine. Here's test point 4 on the other voice. It's working just fine. So yes. So somewhere in between here and here, the signals are not getting there. My guess is it's this transistor right here. There's also IC12 right here. We need to see what that is. That's our saw. Oh, and we can't change whether we're using a saw or a square wave. We should check after this chip, which would be one side of R10. Ooh, where's R10? Good Lord, who knows? That's going to be really hard to determine. We're going to have to look at the layout of the board, which this scan is so bad that you can see that this is the layout of the board. Can we even see R10? Ugh. I really wish I had a better scan of this. This should be multiple color so you can actually see what you're looking for. R30, R6, 1, 15. It's got to be around here. 26. All right, is there somewhere else we can pick it up from? T2. But I want to see it. I want to see it here. I guess we can check on pin 9 of IC12 and see if we're getting a signal, because we were getting signal here. Let's see if we're getting signal on the other side. If this is a switch, that could definitely be bad. IC12, that's kind of what it looks like, is a logic switch. IC12, C9, 4, 5, 11. IC12 is right here. It's a 4016, yeah, that's a switch. And we want to look at pin 9. See if we're getting a signal out of that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we are. We are getting a signal. Wow. And let's check 10 as well. 8, 9, 10. Yep. 9. Yep. Yes. We're getting a signal. Okay. So we're getting a signal here. Yeah, I think this op amp is blown. Just by looking at the voltage that's coming out of it, it's too high. Shouldn't be doing that. So what that would require then is to desolder that, take the board out, desolder it, put a new one in, and that's a big job. And I don't feel like doing that tonight. But I'm happy of where we've gotten so far with this thing. because we've gotten 2 voices working. 2 oscillators, I should say. And I think that 4016, that might be bad because it's not switching. That 4016, well, that's, no, because that would mean every single 4016 is dead. I think this is more of a decoding problem, encoding, decoding problem. I think it's on the panel itself. Sorry for the long video. This is how I work on these things. I just kind of walk through it and figure out what's happening. I'm not an electrical engineer. I just understand schematics and I can follow circuit flow. So I just have to talk it out and be like, what is it this? No, that doesn't make sense. Is it this? No, that doesn't make sense. So yeah. I wish I could find a printed service manual for this set. That would be really sweet. But that's where we'll leave it. We'll come back after I get home from the stuff that I got to do. I'm going to be gone for a while, so we'll come back to this later. All right, after several weeks, I'm finally back at the DK600, and I've got my oscilloscope probe attached to test point 5. If we look at the schematic, test point 5 is right after the op amp that's mixing the 2 signals from waveform A, waveform B. So right there, right? They come in on the negative side of the inverting side of the op amp, and we should see a nice healthy signal right here. And instead, what we are seeing on the scope is just about 4 volts just sitting there doing nothing. Actually, it's 13 volts, sorry. About 13 volts, which is like the supply, power supply of the chip. If I go to test point 5 of the other wave, or the other voice, look at that. We see a nice waveform here. Let me boost it up a little bit. See that? And if we play something, it changes. See that? So, my suspicion is our issue is IC13, which is the mixing chip, which is right there. And one side of it must be dead because it uses the same chip for each pair of voices. So this is 2, and this is voice 1. And it's using one side. This is a dual op amp chip. It's a, what is that? It's a TL082. It's very common. So it's using one side for one voice and the other side for the other voice. So in order to change that, what we're going to have to do is remove this board and desolder that chip, put a new one in, and see if that solves the problem. And desoldering the chip from this board is going to be a little hairy. I'm going to try to do it without having to take off any of these connectors. I'm just going to unscrew it and flip it up. Use my desoldering gun to desolder it. Looks like there's no screws holding it underneath the key bed. There's screws here, 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 here. Okay, shouldn't be too bad. Then the other thing we need to fix on this is some of these buttons not working. Some do. Some do not. Like these are not, that one's working, this one is not. I'm still thinking that it might be the 4051s, even though I was getting a decent output from one of them, but I'll have to double check that because I don't remember where we were with that. Okay, so first things first, let's turn it off. Let's disassemble. Let's get the board out of here. It looks like a smaller Phillips. I don't see, oh, there's a screw right there. to take this keyboard out to do this. So very gently remove this. That didn't work. It says very gently, and then it just popped out, and I bent pins, which is dangerous because bending them back, you can break them. I hate these type of connectors because that happens a lot. And I poked myself. Whatever. Okay, so let's get this out of here. There we go. It's actually better to remove these with like a chip puller, but sometimes that doesn't work very well. All right, there's a screw here. There's a screw here. We can see a lot more of those same type of connectors. That's one reason why I don't want to pull them, but we're going to have to flip it. We are going to have to pull them, I guess, because we got to flip it either back or forwards, and this is soldered. Or is this a connector? Oh, that is a connector. Okay, we can take that off then. We can take this off, and we can flip it this way. Great. Ooh, hi buddy. You're long dead. Shouldn't have got in there, bud. Okay, so we need our desoldering gun. Plug that in. Turn that on. Wait for it to heat up. In the meantime, I'm going to get my soldering iron heated up, and I'm going to add a little bit of solder to the legs of that chip because I find that that helps desolder it later. So the chip we're looking at is right here. Oh, that's the wrong tip. That's way too big for what we're doing, so we're going to change that out. Okay. Get our solder, clean our tip. Add a little bit of solder to the tip, and then we're just gonna add a little bit of solder to each of these legs. And again, I find that this just helps desolder the chip. Let's check our desolder gun. It's all heated up. It's at about 450, which is a little too hot, I think, for this board. Let's put it about 425. Okay. Traces on this board are kind of scary, but that looks pretty good. Let's see if we can get that pried up here. We got a leg that's caught. Which one is it? That was it. That one right there. There we go. I see some corrosion on this, so yeah, I wouldn't be surprised if that guy's bad. I'm going to put a socket in because why not? running out of 8-pin sockets. I'll get some more of those. And then pin 1 is facing towards me, so socket will go in like that. I'll put a little tape on it to hold it while we solder it. Okay. Let's solder that. Looks great. Clean off the solder flux with a little bit of IPA. Lovely. All right. And we need to find a TL82. I have 72s right there. I'm sure I have 82s, but I don't know if I have them out. I'm going to dig through my box of chips. It's right here. All right. Get my little leg straightener here. And then make sure our pin 1 is facing down, which it is. It's gonna be a little difficult to get it in there with these capacitors. There we go. Plug this back in. Let's just put a couple screws in just in case we need to do more surgery on this board. I don't want it to move. All right. Put that on. That on. Get the keyboard back in. Might as well put that screw in just in case it is all good, because I can't get to it with the keyboard in. There we go. Here's our keyboard connector. Let's straighten the pins on that just to make sure it'll go in all happy. Oh yeah, one's bent. There we go. One's bent a little this way. Oops. All the pins are in, yes. Okay. Moment of truth. Plug it back in. See if we're getting voice 5. Yep, there it is. That was it, fellows. Turn the noise down. Sounds great, doesn't it? Voice 2. I also hate voice 5 because I want to go left to right, but it's right to left. It's voice 2. Right there. Voice 2. All right, so the last thing we need to figure out is why on God's green earth some of these buttons aren't working. I need to look at the schematic again real quick and determine which 4051s there are. And I think the last time I made a color-coded thing, it's been like a month since I worked on this, to try to find out which things weren't working. But let's make sure we have all the ones that aren't working. So VCF button, half volume is not working. Neither of these. Oh, that one's working. The destination, PWM destination. VCF button, half volume button, the wave buttons, keyboard tracking is working, that's working, that's working. Wish you could turn off one of the oscillators, but I don't think you can. The PWM seems to be working. We have both waves on, so we can't really hear it isolated, but yeah, so it's in here. All right, so let's go look at this schematic and figure out what's going on there. All right, so IC7 is our culprit because that's controlling the half volume button, the wave button, the VCF button, all that. And so we got to figure out what IC7 is. This schematic is so weird it doesn't tell you what the chip is. I'm assuming it's a 4051. I am misremembering. I thought I had color-coded things, but that was for the Cork Trident because it's having a similar problem where certain knobs aren't working. And it's probably a 4051 encoder. Now we got to pull the left panel board here, which means we need to take these knobs off. Everything from here over. Okay. And we need to get these bolts off because it's actually bolted on with nuts. It's nuts. I'm gonna take this guy out and let's get a nut driver of the right size. Kind of a weird design, to be honest, but whatever. Okay, we are out, and there's still no. I thought maybe, if I was lucky, they would have silk screening on the board to let me know which chip was 7, but it does not. And the problem is that the service manual is such a bad scan, it's almost impossible to read which one is which, but that's what we're going to have to do. Okay, so over here, if we go up, I think it's up. No. There it is. IC7. So here's the mess. Can you read that? Because I certainly can't. Okay. That's IC8, IC5. These are just driving the LEDs, though. Ah, those are driving the LEDs. That's not what we want. LEDs are working. We want what's actually coming from the buttons. Depth, speed, no course. DCO waves, B. Okay, IC9. Waves, half volume, P. Yep. This one, IC9. That's it. That's the chip. Okay, can we see a 9 on here anywhere? Good Lord. I guess we can try to find where those buttons are going, because one side of the buttons go to Y1, which is pin 1. One side of the buttons go to Y2. One side of the buttons go to Y3. So, yeah, we should try to find that on the board, and then we can go from there, because this is supposed to be multicolored. So the layers are different colors, and then you can actually read shit. But this scan is so bad, it's a black and white scan. It's freaking awful. Okay. So let's figure out what button we're looking at. We're looking at, oh, I see 1 and 2 right there. Those are all working. So it's the other one. Now this is a different type of chip though. It's got A, B, C, D, E. It's a much bigger chip. Got at least 20 pins. Yes, 20. Oh, so that's this. That's that guy. That's a 7492923. Yeah, it's got to be. I don't know what that is. I guarantee I don't have it. I'm going to have to order one. Let's look it up. 74 HC 923. '16 key encoder. There you go. Yep. I guarantee I do not have anything like that, but let's look in my small. Ooh, what's that? That's the only 20 pin I have. Oh, it's a 374. Yeah, I don't have that. Okay, so we're stuck. Got to order that part. That's what the problem is, I guarantee. That dude is dead. Dead. Okay. Well, we'll end here and we'll pick up when I get the part.
1 week later.
All right, back on the bench with the Siel, or Siel, however you pronounce it, DK600. I went ahead and replaced that chip. It came today, and it did not solve the problem. It's doing the exact same thing. So I traced the connector, which is this guy here, goes into here, and I traced all the connections to the various chips according to the service manual. I got a new copy of the service manual that's nice and clear, and they're all going, that connector is all going into these two chips with a couple lines going up into the third chip. Now these two chips are the same, so I swapped them just to see if the behavior would change at all. It did not. This one is not socketed, so if we wanted to test that, we have to pull it. It's 244, LS244. Oops. What am I doing here? There we go. It's a 244 octal buffer. So it's acting like a buffer in between the output of the encoder chip and the data bus. So that definitely could be a problem if it's not functioning correctly. The other issue, it could be actually this ribbon cable. I should probably test this ribbon cable and make sure we're getting good connection all the way down through the cable before we desolder the chip. So I'm going to go ahead and do that right now. Okay, I went ahead and probed all those, and I'm just putting it back into place now because they probed fine. Connection was fine. Lower this, it'll be easier to get that in. So I think the next logical step, make sure I got these in all lined up. No, I think the next logical step is to get the scope happening. And since this is a buffer, what we should see is an input signal and then an output signal on the corresponding pins. So if we look at the data sheet for it, we got one A1 there, and it should be coming out, it'll show us right here. So it comes in on one, comes out, or that's the ground, I'm sorry, it comes in on one, comes in out on a Y1, A2 comes out on Y2, boom, 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 boom. It should be fairly straightforward. And we should see signals on all of those inputs and outputs. So the thing to do with the scope is test, pin 2, see if we're getting an input, then check pin 18, see if we're getting an output. And just go through it, and if we find one that's not working, that could potentially be our problem. Now, it is right next to the battery. This is not the original battery. Somebody's changed this. They put some little glue underneath it, hot glue. It's possible that the battery leaked and there's some damage around in this area that we can't quite see, that they didn't fix. So I'm half tempted to pull this battery up and see if there's anything underneath it. I don't think I see some vias under the glue, but they're going to different chips. What we're concerned about is right in here. There are some vias right next to this connector, but I did use my continuity check on the meter, and I made sure all the pins to here were going to these chips, and they are. There's direct connection there. So I don't think that's the problem. We could check the data bus next to make sure that because this buffer goes straight to the data bus. If we go back to the schematic, right there, we can see it goes onto the data bus right on those pins. We could check those. We could check the master data bus going into any of these other chips and just seeing if we're getting a connection. So where's our data bus here? Right here. So IC7, we could, all these should be connected. This is just one big bus. And yeah, this is literally, there's that, there we go, there's the in, there's the out. So 2 to 18, it shows us right there what the direct connection is. So that's what we need to check, I think, next with the scope, is to, when the thing's powered up, see if we're getting an input, see if we're getting an output. Interesting conclusion here. So if we look at this and we go to F6, which is on pin 11, I'll connect my probe to that, which right here. We don't see anything on the scope, but however, see if I can do this with, I'll get in the way. If I press the switch, one of the switches that isn't working, watch the scope, goes up to 5 volts. See that? See if I can zoom in on the scope for you. Sorry about my crappy camera technique here. It's the best I can do. All right, there's the scope. I'm going to press the button. It goes up to 5 volts. So the signal from the button is getting there. Now what's interesting to me is that both LEDs are lit. I'm going to bring this panel down so you can see that both LEDs are lit, and if I press the button, nothing really happens. I'm wondering if we plug in the output, that's when we actually listen to what's going on, if we can turn off one of these waves, which I don't know if we can. Okay, I was wondering if, because the LEDs aren't turning off, if it was actually functioning. Definitely not. We should definitely hear a change. So it's not functioning, the LEDs are not working. That's interesting to me. I wonder what's driving the LEDs. But anyways, what we saw on the scope is we saw, when I pressed the button, there was definitely a state change. Now looking at the output, all I see on the output is the data bus. It's pretty much impossible for me to see if there's something happening because there's so many other things happening on that bus, you know what I mean? So I don't know if that data is actually getting through the chip. I can't tell because all I see is data bus. Here, I'll plug this in, or turn this back on so you can see what I'm talking about. And we'll go over to the scope, and if I go to the output pin of that input was on pin 11, output is on pin 9, to connect our probe to the ground here. And we go to pin 9, which is right here. Hope you can see that. It's just a bunch of data bus stuff. I mean, that's what it looks like. So, part of me thinking that chip is bad. We could test that by pulling it and testing it in the retro chip tester. I should check to see if the retro chip tester can test that 244 or not. I think it can. And then I need to see if I have any. I might. I doubt it. And playing around with some things, I discovered something interesting. So I've created a patch. It's ugly, but whatever. If I was testing the program select to make sure it works, and I read through the manual to figure out how to record a patch to a memory location to make sure that worked. So if I go to 01, see there's nothing there. If I go to 10, where I saved my program, we're back to where we were. Great. Now, here's what's interesting. If I press one of these buttons that is not working, like half volume, look at this. It starts flashing, which means the program has been edited. I don't hear the change, but it says it's been changed. Again. See? So let's save a new program. Let's save this to, so what we do is go to 95, press enter. That goes into record mode. I don't know how to record to an existing, so if we go to 95. Let me try this again. So select MIDI internal, yes. Go 95. That should put us into, we'll start over. All right, so if we go to 95, so there's our new sound. To write it, I think we just go to 10. That should be our other sound. Yep. Go 9. Cool. Again, if we press, we can definitely hear it's not doing it, but it says it is. It says it's being edited. I think that's probably because these two boards are connected together. So I might be on a little bit of a wild goose chase here. If we go back to the service manual and look at the panel, yeah. Here's the programmer. Sorry, right here. And so it's getting, yeah, the data right here, M1, M2 into here. That's another 293, the same one we just replaced on the other board. That's what I wanted to check to see if it was working. So I think all that we're seeing is that it sees that the data is these buttons are transmitting data. It sees that. If we go back to 09, like anytime we press anything, anytime we move a knob, and now it's saying that the program is edited. So we obviously don't hear the change because it's not getting through to the rest of the machine. So the problem definitely is not in the programmer. Ooh, what just happened? Okay, so I tried my desoldering gun and wasn't having much luck. So I've got the area now surrounded by Kapton tape. And I'm going to use my hot air gun here. I'm going to try to get this thing off. Just got to wait for it to heat up. So the Kapton tape prevents the heat from getting onto stuff we don't want. a little messy here. See if I can. Put it back from here because I do want to get the edge of that chip. So I'm just waiting for the little dot here to stop blinking, which means it's at temperature. Going for 400 degrees. We're getting there. I think it's supposed to stop blinking when it's done. Actually, I think it is done. Okay. Getting there. There we go. Yeah, the other pieces are a little hot, but not too bad. Check our traces underneath. Those all look good. I'm gonna add a little solder to a couple of these and then desolder them with some wick to get the holes clean. Wait for that chip to cool down and we can test it in the retro chip tester. That was a pretty clean pull, actually. That's sometimes the best way to do it. Okay, let's get this hole clean. Nice. This one. Nice. Good. And then this one. Great. Let's clean that up a little bit with some isopropyl. Right there. Looks good. Let's clean up the bottom here. Nice. Okay. This should turn off automatically. There it goes. You have to twist it a certain way. You can see the temperature going down. That's good. We want it to shut off and cool down. Okay, so now we need to get the retro chip tester out and test this chip and see if it's functioning correctly. I seem to have misplaced my little tool for straightening pins. This definitely has a pin that needs straightened. Okay, we want to test a 244 LS74. So we want to go to Logic 7400. What do we say? 244. Doesn't have it. Well, that's a drag because it didn't have the other one either, and that was one reason I couldn't test it. And then I ordered another one, and then that wasn't the problem. Wait, I said 244 or 244. I'm an idiot. There we go. Says it's fine. So it's not that. Well, that's frustrating. So the pin broke off when I tried to get it in the socket because it looks like these legs have been slightly cut and they had a little bulbous thing on them. So I'll just order a new chip, put it in the socket, and we'll go from there. And we got to figure out what the rest is going on here. I've got some chips on order since I messed that one up. That was a mistake on my part, and you know, those kind of things happen. So I'm not too worried about it. Yeah, I also ordered some of these chips over here, which are 377 flip-flops. And here's why. I started thinking about the fact that the LEDs were just staying on, and these are what are driving the LEDs. Okay. Oops. So it starts on this E connector, E1 through 8, E9 through 16, 17 through 24, 23, whatever. If we go back up to the panel board here, we can see here's all the LEDs. Sorry. Here's all the LEDs. I'm going to get right at my pointer. And there's my DigiKey order. Yeah, yay. Okay, so thank you. So we can see that that button right there, sorry, the half wave, half volume, that's not working. The VCF is not working. The wave is not working, and this wave is not working. These are all not working. The next thing that isn't working is LFO3 wave right here. This is our pulse width control, or I'm sorry, VCO-A, VCO-B. Right here, this is what assigns LFO3 to those different VCOs. So it's 16, so if we look at it from a diode standpoint, it's 16, 15, 12, 11, 10, 9, 8, 7. Okay? So, if we go back over here, we can see this is the E connector. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm sorry, 9 and 10 are our first ones that aren't working, VCO-A, VCO-B. And we have 11, or sorry, 9, 10, 11, VCF, 12, 13, waves not working, 14, 15, waves not working, 16, that one not working. What's the commonality between those? All those lines that aren't working? This chip right here, 9 through 16. This guy, this 377 flip-flop. Now, the confusing thing to me is why would it matter if this wasn't working if all it's doing is driving the LEDs? But it's on the data bus. So if it's throwing weird data back into that bus at the same time that the other chip is trying to send data for those switches to be turned on and to affect what they affect, then that could be throwing the whole thing off. So I'm starting to think it's this chip right here. Hey, this is post-video Jim, and the reason why this chip is doing the LEDs and also affecting the rest of it is because I didn't even think to look at the other numbers. Yes, it's going E9 through E16, but look, it's also going L1, 2, 3, 4, L22, and then S9 through 16. So it's actually driving multiple things. It's driving the voice board and it's driving the LEDs. And that's why, if that chip is bad, That's why those buttons are not working, nor are the LEDs that are associated with those buttons working. All right, I removed IC20, and I just tested him in the tester, and look at that. Make sure he's in there correctly, but I'm pretty sure that's our problem. Yep. So what we could do, I was thinking about this earlier, what we could actually do if we wanted is, I have that DK700, which we remember got the voice chip out of. It has, the motherboard is almost exactly the same. I think it is the same actually. We could take this chip and we could take this chip out of that one and see if both of them work and put them in. I'm a little concerned about this socket. I might actually just take it out because I don't think, if I do take the old chip, I don't think it's going to fit in there. I did order new chips, but it's going to take a couple days for them to get here, and I kind of want to get this wrapped up, to be honest. I think I might do that. I did the hot air thing again on this. It came out really nicely. Didn't damage anything, didn't damage any traces. So I think that's really the way to go, and I think I could get both of them out from the other board. Here we are in the DK700, and in closer inspection, we can see some serious corrosion from the battery that I took out earlier on a lot of these chips. So this board might be shot anyway, so I'm not feeling too bad about stealing chips out of it. This thing might just be a parts machine. So I am going to attempt to take this chip out. I already got this one out with the hot air gun. I didn't even have to take the board out, which is nice. So I'm going to try the same thing on this one, and I honestly, yeah, there's more. Ooh, this thing's a mess. This board might be shot. It would not surprise me. This is kind of a rare piece, a little bit. I mean, you don't see these very often, but honestly, it's the same voice architecture as the 600, and the 600 is way more fun to use because of all the knobs. This is, you know, you got to edit things with, yeah, not as cool. So I don't feel so bad, and this could just be like a parts machine in case any of the chips and the voices go down on the other one, because this has the same exact voice board. So that's why I'm going to treat it, I think, as just kind of a spare, because this CPU board is a mess. I noticed that this chip over here is the exact same chip as this. It's a 244. So I decided to take this one out because there was less stuff around it and it looked better. This one has some corrosion around the pins. So I've got that out right there. I'm waiting for it to cool down so I can test it. The pins are actually a lot cleaner than the other one. So I might be able to get in that socket, but I'm not going to force it. If it doesn't go, I'm just going to take the socket out. So we're basically done with this. We can take this off the bench. And unless, of course, this tests bad, then we'll have to try another one. Again, we can do that right now. I'm just kind of waiting for it to cool down because it's pretty toasty. Let's see. So this guy tested good. And this is a 244, so let's go down there, or 224, 244. Looks like this. Great. So both of these chips are working. And that means you can ditch this bad boy and put the key bed back into it. All right, with a little bit of monkeying around, we got it in the socket. So now it's time to put this one in. We're going to solder that because I don't have any sockets, and the sockets kind of made things harder anyways. Ooh, this is exciting. Got both chips on there, and we're ready to put it back into the 600 and see if it works. They look really nice. Okay, we'll get rid of our retro chip tester. This is our dead chip. We'll throw that in the dead parts bin. There she is. Okay. goes. Put a couple screws in just to hold it in place. Just combobulate that here. Where those screws go? I think they're these right here. And we'll put one in right there. Another one in right here. Just broke. Can't tighten those down too much, they'll just break. I might glue those down later. That's going to be, flopping around. This one's already broken. I didn't break that one. It's these little nubbies here that are breaking off. Oh no, I'll put some glue on it, but that's enough to get it held down right now, just for testing. Okay. So pins are going in the correct slots here. This is F. This is G. That did not feel good. There we go. There we go. And there we go. And there we go. All right. I'm going to take off my ground just for the time being because I'm pretty confident. Maybe I shouldn't be, but I am. All right, moment of truth. Yes. Yes. See if our guy's still there. No, nothing there. So that battery's totally dead. There we go. Got a bad contact on that key. To figure out what's going on there. It might just because this thing is out of alignment. Great. So the next thing we need to do is figure out this key bed. It's not holding patches, which means the battery's probably dead. That's not surprising. So we'll have to replace that one that's already been replaced. We'll get something for that. And yeah, the buttons are working. So I'm going to call this one pretty much fixed. I got to find a way to glue this little piece back onto here. I already used super glue and it broke off, which I'm not surprised. I might need to drill some little holes in and do some pins or do some plastic welding or something. I don't know. We'll figure that out. But Yeah, this keyboard needs to be redone because the dynamics aren't really working very well. Maybe that's why that one's sticking on, is one of the contacts doesn't seem to be working, so it's not doing dynamics at all. Yeah, see, now it's stuck on. Pretty cool. Calibration and all that stuff needs to happen, but we got the main problem fixed, so awesome. So that was the Siel DK600, and it's fully working now electronically. We just gotta get the key bed cleaned up and fix a couple mechanical things. But what an interesting synth. The design is very unique, and I enjoyed learning how to repair it and learning how it works. And thanks to the Vintage Synth Repair Forum on Facebook for kind of describing to me why IC20, which was a 74 LS 377, which looked to be just driving the leads, why it actually was affecting everything else, and how it had multiple destinations, because I just didn't notice that. So anyways, if you like the video, like and subscribe, put a comment underneath if you have any thoughts or comments about how I approach things. You know, not a professional electronics engineer by any stretch of the imagination, but I like tinkering with things and I enjoy fixing things and figuring things out. So hopefully you do too, and we'll see you on the next one. All right, take care.